Welcome to describing rotational motion. In this video, we will go over the MCQ of this lesson. Number 1. Which of the following is a unit used to measure an object's rotation? Rotation means we're talking about an angle. So basically, it is the radian in the international system. Question number 2. One complete revolution, which is 360 degrees, is how much in radians? So we know that half a circle is 180. A full circle is 360 degrees. One circle is only a pi in radians. A full circle is 2 pi's together. So in radian, it is 2 pi. Question number 3 here. How many degrees correspond to a radian? If you want to solve it manually, 1 radian, if I want to convert it into degrees, I put here up degrees and down I put radian. So basically I have 2 pi radian in every 360 degrees. So by computing, I will have it as 57.3 degrees. Later, what is the angular displacement? Angular displacement is the change in object's what as it rotates. So angular displacement is nothing else than the change of position. So basically, change of the angle. Later, the angular what is equal to the change in angular velocity divided by the time. So what is the change in the angular velocity, W, divided by the time? So it is the angular acceleration. Yes. Question number 5. A rotating disk has a knob on the edge of it. The disk completes a rotation every 3 seconds. So it does a 2 pi every 3 seconds. Using this information, you can calculate the angular what of the knob. So here, basically, I do have the angular displacement and I do have the time. Given these two informations, I can figure out the angular velocity, which is the change in angular displacement over the time. So the angular speed or velocity. Question number 6. If an object is rotating in a counterclockwise direction, so in a counterclockwise direction, in this direction, so basically it is taken to be the positive direction. Question number 7. What is the arc length for an angle that is equal to 2 radian? The 2 radian eventually here, 2 rad, is actually the angular displacement. And what is the arc length is meant by the linear displacement in terms of radius, and radius. However, here we have a relationship between the angular displacement and the linear displacement. Given the angular displacement equals to 2 rad, delta x is actually after cross multiplication, delta x equals to 2r, giving twice the radius. Question number 8. We have a car that has a linear acceleration of 1.8 meters per second squared. Sometimes we call it the tangential. And the radius of its wheel is 0.3 meters, r. What is the angular acceleration of the wheel? So alpha, the angular acceleration, equals to the linear acceleration divided by r. However, r is in the proper unit in meters, so it is 1.8 divided by 0.33, and it will give me a 5.5 radians. This is a radian per second squared. Later, the figure shows a cylinder of radius 0.7 meters, rotating about its axis at 10 radians per second. The speed, and here he meant by the linear speed, what is it? Now we have an equation that says that the angular speed equals to the linear speed divided by the radius. However, W is 10, V is unknown, R is 0.7. After cross multiplication, V equals to 10 by 0.7, which gives me a 7 meters per second. In question number 10 and 11, we have the radius of the CD below is 6 centimeters. Now, just before we go ahead, this radius, if ever I want to use it, I need to convert it into meters, so it will be a 0.06 meters, just in case. And the angular velocity, W, is 5 radians per second. Question number 10, given R, given W, I need to find the angular displacement, which is delta theta, in 2 seconds. How can I find it? I'm given W equals to the angular displacement divided by the time interval. Now replacing everything by its value, I've got a 5 equals to the angular displacement divided by the time 2. After cross multiplication, I have 10 radians. Question 11, with the same parameters, what is the linear here? What is the linear displacement? And meant by it, I need to find delta x of a point on the edge in 2 seconds. However, there's a link between the angular displacement and the linear displacement, which says delta theta equals to delta x divided by r. The 10 radian that I just got up, I replace it here. So delta x, and the radius, if we remember, we got it in meters. It is 0.06. R is 0.06. So delta x equals to 10 by 0.06, giving me 0.6 meters. Option B. Question number 12. I have a free wheel of diameter of 1.2 meters. Has a constant angular acceleration, alpha, 5 radians per second squared. The tangential acceleration of a point on its rim is how much? So basically, I need to figure out A, given alpha, and here I do have the diameter. is 1.2 meters. Now eventually I need the radius, which is half of the diameter, half of the 1.2, which is 0.6 meters. Now alpha equals to A over R. Replacing everything by its value, 5 equals to A over 0.6. By cross multiplication, A equals to 5 times 0.6, which is 3 meters per second squared. Option A. Later, an antique long playing record rotates clockwise at 33 revolutions per minute. So basically, just for the info, this is the unit, or this is the parameter of the angular velocity. Now what is its angular speed? Yes, in radians per second. So I'll put my 33 that I have in revolutions per minute. However, I need to convert the revolution and I need to convert the minute. I need to convert the revolution, so I'll put rev down, and I want to have the radian up, so this way I can cancel out the rev. Later I need to cancel out as well the minute, so I'll put minute up and showing seconds down. I know that I have in one revolution I do have 2 pi radian, and in 1 minute I have 60 seconds. So I'll compute 33, here it's, to be accurate, it is 33.3 times 2 pi divided by 60, which is 3.49 radians per second. Question number 14. We have a free flywheel increases its angular speed from 5 radians per second into 15 radians per second in 5 seconds. So, what is its angular acceleration alpha? Now, I do have the initial angular speed, 5 radians per second. I do have the final angular speed, which is 15 radians per second. I do have the time interval, which is the 5 seconds. So alpha equals to W final minus W initial over the time, which is 15 minus 5 over 5, and this will give me a 2 radians per second squared. Later, question number 15. When a fan is turned off, its angular speed decreases uniformly from 10 radians per second to 6.3 radians per second in only 5 seconds. Again, I need to find the magnitude of the angular acceleration. Given the starting angular speed or angular velocity, radians per second, and the final angular speed, 6.3 radians per second, and the time interval in 5 seconds, alpha is W final minus W initial over the time interval, which gives me 6.3 minus 10 divided by the time. The time is 5. The answer here is actually negative 0.74 radians per second squared, but as he needs only the magnitude, so I can have it as the absolute value, which is 0.74 radians per second squared only. Lastly, I've got a car whose tires have a radius of 32 centimeters. Now let me convert it into meters by dividing it by 100. So R is 0.32 meters. Travels down a highway at 25 meters per second. That's the linear velocity. What is the angular speed of the tires? Given V and R, W is V over R, which is equal to 25 over 0.32. That is equal to 78 radians per second. Option D. Thank you.